Potential and kinetic energy practice. Here is our practice worksheet. All right. Now, as I always have with practice, the front side, we've got some notes here. Top section dedicated to potential energy. Here you have the formula all labeled for you. A practice example. Some examples over here. The more mass, the more potential energy. The more height, the more potential energy. Okay. Little reading right there. Give you some words to back it up. Talking about this over here. Some real life examples. The potential energy helps us generate electricity in hydroelectric dams. Okay. Now kinetic energy. Kinetic energy, energy of motion. Giving you a formula. A little practice calculation there. Some nice concepts. Some more concepts here. More mass equals more kinetic energy. More velocity equals more kinetic energy. So we've got some nice notes there. Good way to summarize it. New way of looking at it. Fresh perspective. So if my notes don't help, this might be more helpful. Alright, on the back, we've got some sections we need to work through here. So, let's start on this first section. So, doing the matching thing again. Again, lowercase p, that is momentum, a concept I have not taught you yet. So I'm giving you the answer. It is the kilogram meters per second. Okay? So that one's off your list. Okay, everything else, F, V, H, W, or E, and uppercase P, you've been introduced to all those, so you should be able to match those units accordingly. I will give you a little hint. F, force, FW, force of weight. Force is always measured in newtons. So that crosses that one off there for you. Okay? Just giving you one extra. All right, the next section, potential energy or kinetic energy. Now you see how this is EP or EK. You don't have to write it that way. If you can if you want to, but I would recommend you just kind of stick with the way I've been doing it in the notes. So, a car is traveling at 45 miles an hour. Okay? Car means it has mass. Miles per hour tells you it's got some velocity. So if a car is traveling with velocity, what kind of energy do we have? Well, let's just take a little look at those formulas again. Kinetic energy, 1/2 mass velocity squared. Potential energy, mass, gravity, and height. They both have to deal with mass. Okay, they both have mass, so that's upside. The key to the difference between these two formulas is that idea of kinetic energy has velocity and potential energy has height. Okay? So, keep that in mind. If it's traveling 45 miles per hour, that's velocity. We're talking about kinetic energy. A rock is on a ledge 5 meters high. Height, that's potential energy. Okay? Ledge. You're going to see that word a couple times. Just to clarify. Imagine a cliff. You're standing down here. That rock sitting on the edge is actually called a ledge. Hence the name ledge. Okay? Sitting on the very edge of a cliff is sitting on the ledge. Or the ledge of a bookshelf or something like that. Okay? So sitting on the ledge means you're just about ready to fall off. I'm going to let you do the remaining 3 on those. Circle the one. So circle the one with more kinetic energy. So remember, kinetic energy equals 1/2 mass velocity squared. So we're caring about both the mass and the velocity. So we've got 25 kilograms or 30 kilograms. They're both going the 5 meters per second. So 25 versus 30, 30 kilogram object has more mass. If it has more mass but the same velocity, we'll have more kinetic energy. Okay? Let's do the third one down. A car at rest or a car rolling down a hill. Okay? So, at rest means the velocity is 0. rolling down a hill. Rolling means it has a velocity. Okay, so which one has more velocity? That's the one that's going to have more kinetic energy. Okay, so greater velocity means greater kinetic energy. Greater mass means greater kinetic energy. Okay, over here to matching. Kinetic energy, potential energy, work, joules, and H. Match them up here. This one says energy of position, units of energy, units for energy and work, energy of motion, how far above the ground an object is, and uses energy and can create energy calculated by multiplying force times distance. Alright, so there you go. Uses energy and can create energy calculated by multiplying the force times distance. It's calculated force times distance. What does that look like? Work! There we go. So we've done the first one for you. Okay. Circle the one. So circle the one with more potential energy. Potential energy is mass times gravity times height. Okay? So if it's got more mass or more height, it has more potential energy. So a car at the top of the hill or at the bottom of a hill. Which one's going to have more potential energy? Well, mass is the same. Height, that's what's different. Bottom of the hill, top of the hill. Top of the hill definitely has more height. Okay? A plane on the ground or a plane in the air. Which one's going to have more potential energy? Well, the plane in the air because it has more height. Okay? Alright, you guys can do the others. Alright, now to the calculations. So, problem solving process. Write down every number. 5 kilograms. 3 meters. And what are they measuring? Kilograms measures mass. Meters. Meters. Okay, meters measures distance normally, but we're talking about a 3-meter ledge. That's actually more specifically to height. Okay, so you have to kind of be careful sometimes if it's asking for distance or it's asking for height. Both measured in meters, it's just a matter of your perspective. Are you looking up or are you looking across? So we've done the first steps. Next very vital important step is asking for the potential energy. Potential energy. Okay? Potential energy formula is mass times gravity times height. Well, we know the mass is 5. We know the height is 3. Gravity. For this worksheet, to make the math easier, we're going to ground gravity to 10. Okay? So, little note at the top. We know that gravity equals 9.8. For this worksheet, round gravity to 10. Okay, but for this worksheet, not for your quizzes. Okay? Just to simplify the math. So 5 times 10 times 3. 5 times 10 is 50. 50 times 3 equals 150. I'm solving for potential energy. Energy is measured in joules. And there's your answer. A few extra hints on some of these problems. Okay, this question right here, the 25 Newton object up 3 meters, how much potential energy does it have? This one's kind of challenging because it's expecting you to have read very carefully a very particular note on the front side. So here we go. Take that, flip it over. There's a very small little but yet important note right here. Okay? That will be essential for you to be able to solve that question right there. Okay, so right now you might want to highlight that, make some sort of note that is the hint you're going to need to be able to solve that problem. Okay? And then the next question, all right, it tells us 3 kilograms is mass, 300 joules. We know that's energy, but here's the catch. It doesn't tell you which type of energy. It just says energy. But then it asks the question, how high up is it? So you have to answer the question, which type of energy are we dealing with if height is the question? Okay, so is this going to be kinetic energy or is it going to be potential energy? Okay, so that's the question you have to answer there to be able to know which formula you're going to use. Okay, over on this side, the one with a rolling ball, okay, this one requires a rearrangement of the formula. Use your journal to find the formula because you need it rearranged, and that's where get that complicated algebra going on. So you need use your journal to rearrange the formula for both of those two questions right there. Okay, and then your last little hint for this one, the formula is from a previous topic. So it's not, you're not going to find this on, you're not going to find it in this worksheet. You're going to have to look at the previous page in your journal. So work through these problems carefully, okay? Go through the problem-solving process. Identify your variables. Identify the question. Don't skip that. Show me your formula. You must show me your work on the calculations to get credit. Alright, you need to understand the concepts as well. Don't just jump over this. Don't just copy it from somebody else. Hopefully you have learned by now that if you just copy the worksheet from somebody else, you will fail the quiz. You need to do the whole thing. You need to understand it. Now, if you get stuck, turn to a neighbor, ask them, I don't understand, how do you do it? Don't say, hey dude, what's the answer? No, work it through, discuss it, learn from one another. Okay? Show your work. Work through the problems. Remember, I've got some great notes here on the front side that can be very helpful. Okay? In theory, you should be able to do everything using just these notes. Everything on the back side. Okay? But work through these. Let your brain process each one of these questions. You'll learn it better. Okay? You'll remember it. And then, of course, it's always a good idea to go through it one last time before you go to bed so your brain puts it into your long-term memory. Okay? So get the work done. Check your work with your neighbor. When it's all done, you're going to glue this in to page 31, titled Potential and Kinetic Energy.